Hello, algebra students. We have one more section for chapter 11. We've been working with chapter 11 for a little bit. We had square roots, we had things that were squared. So geometric sequences is going to fall under that a little bit. This should look familiar. We have done stuff called arithmetic sequences before, which we're actually going to compare and contrast the two down here. So our essential question is, can I identify geometric, and I'm going to geometric, and I'm going to add and arithmetic. Now, if you were in my math class, we talked a little bit about arithmetic. It looks like arithmetic, and arithmetic is adding and subtracting, right? So arithmetic or arithmetic sequences are when you add the same number or subtract the same number every time. Whereas geometric is multiplication and dividing the same time. So you multiply by 5 every time, or you divide by 2 every single time. So let's compare these. I'm going to use two different colors for this. So my suggestion is to pause this video and go get like 2 colored pencils or go get 2 pens. But we are going to compare arithmetic and geometric. Some of this should be review, and then some of it will be new here. So arithmetic, this should look familiar. F of x is equal to mx plus b. We have been really familiar with this mx plus b because that's also our linear function. Arithmetic is linear. When you graph arithmetic, you get a line. In fact, why don't we draw that? In arithmetic, you get a line, whereas in geometric, you get this like arc. And it goes all the way up like that, this exponential curve. So let's look at this. This m, we call that the common difference. I'm running out of room here already. Whereas that b, does anyone remember? That is our zero term. So when I had my arithmetic sequences, for example, this is an arithmetic sequence. I'm going to write it out. If I start with 4, 8, what am I doing here? It's arithmetic, so I'm I'm adding 4 every time. So I'm going to add 4, I'm going to add 4, and I'm just making this up. So if you're like, where is she getting that from? I'm just making it up. I'm telling you what to write down. So this is an arithmetic sequences, or a sequence. Sequences go on for forever, and you'll notice it's arithmetic sequence because you're adding 4 every single time. So that's the difference between arithmetic and geometric. Let's look at geometric. This is your brand new piece. So geometric has a different equation, and this is what it looks like. A, which is a variable, we can plug stuff in for that. B to the power of x. So notice how they both have x's, and they also both have different variables, so let's kind of look at this. There is a zero term. In this case, a is actually the zero term. And we'll talk about what the zero term is a lot tomorrow, or our next day that we're going to be working on 11.1. And the b, instead of the common difference, which is the difference, there's 4 between the two numbers, that's the difference between the two numbers, we call this the common ratio, which is what you're multiplying, it's what you're multiplying by. If you're dividing, you just multiply by a fraction. If you're dividing by 2, you're technically multiplying by 1/2. But again, we're going to go into all of that later. So this would be an example. 2, 6, and then depending on what comes next, for example, how did I get from 2 to 6? Not by adding 4. That would be arithmetic. This is geometric. So what am I multiplying by? I'm going to multiply by 3. And I just keep doing that over and over again. So multiply by 3, you get 18. That was a multiplication symbol. Multiply by 3, you get 54. It's kind of hard to do in my head. Multiply by 3, and you get 162, etc. So that is the difference between arithmetic, something that should be review a little bit, and then geometric, something that's brand new, but looks very similar, right? There's still sequences, there's still a sequence of numbers, there's still formulas, there's both zero terms, in this case the zero term, like over here the zero term is what comes before that. So the zero term over here is like what, 2/3, because what do you multiply by 3 to get 2? Whereas the zero term over here would be 0 actually, because 0 plus 4 would be 4. And again, we'll go into that a lot tomorrow, but I wanted to clarify any questions. So I have 6 examples. So we did the information that you need today, which is also going to be really important for the next few school days that we're doing this. But let's do some examples, because all I'm going to ask you to do today is for you to give me an A, G, or an N, which means, is it arithmetic, is it geometric, or is it neither? Is it just like numbers that don't actually have a pattern or don't have a pattern that we can easily distinguish as arithmetic or geometric? So let's look at this. 2, 6, 10, 14, etc. That is an ellipsis, ... That means it's going to keep going using the same pattern. Okay, so let's look at this. There's obviously a pattern. There's something going on. I always check because sometimes it's like +4, +5, +6, and that's not arithmetic. We need it to be, we need the same thing to be happening. And in this case, like I could multiply 2 by 3 to get 6, but if I multiply 6 by 3, I don't get 10. So in this case, hopefully you've already recognized that it is +4, and if you're adding the same, I keep pointing up there, sorry, if you're adding the same amount, that is going to be arithmetic. And that's all you need to be able to do today. So look at a sequence and say, I know what I'm talking about. Look at an equation, which we'll do that next, and figure out what we're talking about here. I'm running out of room, so I'll already do 2 there. 2, how about this? 4, 20, 100, 500, etc. That ellipsis means it's going to go on. Okay, I already know it's not arithmetic, because 4 plus 16 is 20, but 20 plus 16 is not 100. So it's not arithmetic. The same thing isn't being multiplied every single time. Let's look at geometric. It might be geometric. 4 multiplied by what is 20? Well, it's multiplied by 5. And 20 multiplied by 5 is 100. So far, so good. 100 multiplied by 5 is geometric. Geometric, because it's 500. I don't know what I was saying there. I was like, it's already geometric. But 100 times 5 is 500, etc. And you could continue that. And so far, so good. My geometric, I might ask you, what is the common ratio? And you would say it's 5. My common ratio is what's being multiplied. Let's look at this one. Okay. 4, 9, 16, 25, 36, 49, continues on that pattern. Okay, this is a pattern. You've seen this before. Is it arithmetic, meaning the same number is being added every time? Well, 4 plus 5 is 9. 9 plus 7 is 16. So I already know that if this is 5 and that's 7, that's not arithmetic. Geometric, 4 times 2.25 is 9, I think. And that's not the same there, so I know that it's not geometric. I could try and find a pattern there, but it's not. So this is actually neither. Now, they are perfect squares, but not geometric or arithmetic. So if you wanted to give yourself like a little like, hey, but I thought that was familiar. You are right, but it's just not arithmetic or geometric. It happens to be a sequence. Any set of numbers is a sequence. It's just a matter of what, is there a specific pattern? So that is something you need to be able to do. There is something else you need to be able to do. So my next 3 problems are going to be, can you look at an equation or at a function? Why don't I try this? 2x plus 4. So it has an x, which both of these do. There's an x there and there's an x there. What else is going on? I know that there's a number in front of the x. The x is not an exponent, so I already know it's not geometric, because the x is not an exponent. So then I start looking and I look if I can compare these. So mx plus b, 2x plus 4. What is my m? My m would be 2, my b would be 4. Ugh, I know that it's arithmetic. So I'm good to go there. Awesome. Let's try another one. f of x is equal to x squared plus 4. Ooh, so there's an exponent. Is it geometric? Let's compare. It's not geometric because the x is not in the exponent. The x has an exponent, x squared, but the x is not like the exponent. And so it's not geometric. Let's look at arithmetic over here. There is an x and a plus b, like 4, it's plus b plus 4. But for arithmetic, there is no exponent. So look at this. This is x squared, and this is just x. So it's neither. Almost spelled that wrong. It's neither. I don't care how you say it. It happens to be quadratic. If you really care, you can write that down. If you're like, I don't want anything new in my brain right now, this is more than I can handle, then don't write that down. You don't need to know that. It's just that it's not arithmetic and it's not geometric. Let's look at, one more. I don't know why I put that as a 9. 6. Let's put one more. How about this? The next. Okay. Firstly, not arithmetic. Arithmetic has a big X, not an exponent for the X. Let's look at this. So there is an X in the exponent. So I know I'm already getting closer to geometric. That's really loud when I go back and forth. Sorry. I'll pick it up here. So we have A times B to the power of X. And we have 2 times 8 to the power of X. 2 would be my A. 8 would be my B. X is in the exponent. Awesome. I know that it is geometric. So let's go back to our essential question. You need to be able to identify geometric and arithmetic sequences when they are given to you, like when the sequence is written, and you also need to be able to identify them when the sequence, like a function or equation, is given to you.